Hello. Inclined plane is a very classic question in physics. So let's take a look at this question. But before we try this question, let me introduce you some basic idea first. As I said earlier, whenever you approach a similar question like this related to acceleration and forces, the first thing you want to do is draw the free body diagram. And then the second thing that you do is probably dividing the forces into two components, or acceleration into two components, which is horizontal and vertical. And then after that, you'll be using F equals to ma Newton's second law for each of the axis. So this is like the xy axis in your diagram. And then at the end you just solve, and sometimes you may need to use simultaneous equation to solve it. However, in this situation where we have the inclined plane, you can see that the box would not be moving either horizontally or vertically. What we may have instead is, when you have the inclined plane, the box of course will either be going down along the slope or going up along the slope, right? So if you think about this is more like a slanted direction if you are still thinking about the traditional XY axis, so horizontal and vertically. So in that case, if you try to express this acceleration, it will be very complicated, and therefore we would not be doing this for now. So how we can do is we can actually tweak the axis. Instead of x and y like this, we'll actually tweak the axis as in along the plane or perpendicular to the plane. So imagine the new x-axis and the new y-axis. I like that. And then now I will introduce you to what will happen to the force then. First of all, let me give you some time to think about in such a situation, inclined plane. Let's say the box is not moving at all. Given that, of course, the inclined plane and the surface of the box, between them there is friction. How would you draw all the forces? So draw the free body diagram of the box, pause the video and come back to me afterwards.
Imagination.
Okay, so the first force that you should be able to think of should be the easiest force, that is the weight. Notice that weight should always pointing towards the center of the earth. So in our case, since this is the ground, then it should be perpendicular to the ground. Okay, so if you try to zoom out of the whole picture, this is the earth, let's say, then the inclined plane is something like this, and then the box is something like this, and so it will be pointing towards the center of the earth. Nothing to do with the angle of the inclined plane at all. Okay, so the second force that you should be able to think of should be the normal force. And as we call the normal force in mathematics, the word normal means perpendicular. So here we are referring to perpendicular to the surface. So the next force that you draw should be something like this. It is perpendicular, that means 90 degrees with the surface. Okay, and that's the second force. The third force should be the friction. Obviously, if only there are two forces like this, or imagine there is a inclined plane like this without any friction, then for sure that this object would surely go down along the slope. So there must be some friction that holds it up, and of course this force should be pointing up along the slope. So let me try to draw it a bit more precisely. Yes, like this. Okay, so this will be the friction. Okay, so this will be the only three forces that you can draw on to the free body diagram. Next, since we said we want to readjust the coordinate, like the xy axis, as in one is parallel to the slope, this is so-called the x prime, the new, whatever you call it actually. I'll call it parallel to the plane, and also this one perpendicular to the plane. So here I'm just trying to illustrate to you. So in maybe exam, or if you think this is too messy, I don't actually recommend you draw it, just to show you the idea here. So you will find out that for the normal force, it will be exactly the same along the y prime, the new y-axis direction. And also for the friction, it will also be exactly following, or we can call it parallel to the new x-axis direction. So in this case, it will give us convenience. When we try to do calculation, you can just do n and f directly. You don't have to do the sine cosine thingy. The only thing that you need to do here is you have to take care of the weight. So my question is, as we all know in previous chapter in projectile motion, let's say again there's a initial velocity, and I tell you there's a certain angle theta, then what would the horizontal component and the vertical component would be then? Then you should be able to answer me now. By the time you're learning this, you should be more familiar with this. This should be u cosine theta, and this should be u sine theta. So my question is, if I try to devise the two components of the weight, how would you like to draw it, and what is the expression, mathematical expression of them individually? So let me show you the two components first, in case you can't draw it. If you like to draw, of course, you can pause the video and draw it yourself. So when you devise them or decompose them, one should be along the x-axis, the new x-axis. Oh, I erased the friction by accident. Okay, so one should be along the new x-axis. The other one should be going like this. All right, head to tail method. If you remember, in the past you may have heard about this. But then just to illustrate a little bit better, I will actually draw the one like this. Okay, so it's the same idea. And this one will be going perpendicular to the plane. So let me give you some time, pause the video, find out the expression of this. My hint is one of them is w cosine theta, one of them is w sine theta, obviously, given that this angle is theta. Okay, pause the video and think about it first.
2,000 years later.
Okay, so answer time. So for the one that going parallel to the plane, that will be w sine theta, and the one that is perpendicular to the plane will be w cosine theta. You may ask me, how do I know this? I will tell you, because I memorize it.
Yeah.
Okay, the reason is that you will see this a lot, quite often, and eventually you should be able to memorize it. The second reason is that if you try to prove it in the exam, it will take you so much time. So my recommendation is memorize these two. Actually, it's quite easy. Just remember the one that's going down along the slope is w sine theta, and the other one is simply cosine. But of course, at the first place when I learned it, I don't simply memorize. I mean, I have to understand it, right? So the question is, so how can I prove this then? So let me show you. Let's try to extend this from W. So then this obviously is 90 degree. And so you should be able to use a little bit of maths. I think in junior, secondary, you can do it in maths also. This angle, if this is theta, then this angle must be 90 minus theta, because yeah, I guess you know how to find it out. And then this is the opposite angle, right? So this is also 90 minus theta. And so in that case, again, this is a triangle. If you look at this, this is a triangle, and this is 90 degree, and therefore this one will be theta. Okay, so let me clear out those are not relevant stuff, like this one first, okay, to show you a better picture. Okay, so this is theta, and then you can see that once again, the red one, the red W here is the original vector, and so the one that is with the theta, that one will be cosine theta, and the one that is opposite to the angle, which could be this one, but then you kind of move it to here, so then in that case this will be w sine theta. Okay, so this is a proof, and this will be very helpful later on. Just notice one thing: when you are drawing free body diagram, you should not be drawing these two, w sine theta and w cosine theta. You only draw the w, because this is how we do for free body diagram. Okay, so if you're okay with that, then you can start to do this question. You may want to pause the video and try it out by yourself first. Okay, so let's try to understand the question first. The question said, first of all, this is a rough plane, so that means there must be some friction. There are some other question that is said is a frictionless plane. That's fine. Then, of course, you should not include the friction. So here we would simply draw the free-body diagram as what I showed you earlier. And it said, imagine the plane was started with a small angle, and the angle would increase gradually. So you can imagine, you can also try with a book or anything like that is kind of sturdy in your hand, and maybe put your mobile phone on top of it, and you can try to increase, like this is the book, imagine, and the box is like your mobile phone. So when you increase the angle, you eventually find by a certain angle, the phone or the box here will gradually slip down. That is very obvious. I mean, there must be a certain angle, right? The worst case is like if it is really strong friction, then nearly vertical, for quite sure that it will fall down. Okay, so here it said it is 30x degree will be the critical angle where it will start to slip down. So that actually means the friction would not be able to hold it up in that case. Alright, so it wants you to find the coefficient of static friction, which is the mu s we learned in the earlier chapter. And I would say the usual approach that we do this question is the same as what I said. We got the free body diagram. We'll try to divide into two directions. So we are not doing horizontal and vertical this time. As I said, we will be doing parallel to the plane and vertical to the plane. So I will do like this. This is a symbol just for note taking. I would say parallel to the plane. Okay, and on the other side, I will do perpendicular to the inclined plane. So you may want to write it down, because this is very important to show your reader that what you are doing. And then I will again I have to start with F equals to ma for both of them. Give credit to Newton. And then let's just start with the parallel, that one first. So as we said, the one that is going along up along the plane would be friction, and then going down will be the W sine theta. So in this case, this is not moving, right? So then we could actually simply say, well, how about this? F equals to 0, and therefore cos A is 0, right? Because A is 0, and therefore we have the friction equals to the W sine theta. That is all you have, right, along this direction, right, along the plane. Because for N and also the other one, if you remember, W cosine theta will be perpendicular to the plane, so they will be on here. Okay, so similarly, for the perpendicular to the plane, that one, you don't expect the box will also go like fly or kind of sink down into the plane like this. So F would also be 0, net force to be 0 again, because acceleration will be 0. And in that case, you have the normal force equal to the W cosine theta. Okay, and so we actually know that cosine theta will be, I mean, theta itself will be 38 degree. So what we may want to do is we would say theta will be 38 degree, and you can actually substitute here by the time it's about to slip. Okay, and if you look at the whole equation, we have two equations here. We have one unknown, weight. Do we know weight? Oh, actually we know, right? Because we know the mass. So we know mass. Maybe I'll use a black color. So this is unknown. This is known. This is normal force is unknown. So I put a question mark here. Weight is known. So there are two unknown, and there are two equations. So actually we could find out the unknown. But then ultimately you should recall that, hey, we are not trying to find out f and n, we are trying to find out mu s, right? So you have to find an equation that relates to mu s, and that is what you learned earlier about friction, that friction, static friction will be smaller or equal to mu s times normal force. Okay, and since we are talking about it is about to slip, so then the static friction at this point should be the largest value. Okay, it's reaching its maximum value. So over the if you go in a higher angle, then the friction will not be enough. So that's why now the static friction is at a maximum value. So this is the third equation you need, and this will be very helpful. So if you simply combine all these three equations, 1, 2, and 3, what we can do is we could simply sub, I guess, 1 and 2 into 3. So in that case, we have friction, which is W sine 30x. I would say actually we don't actually need to know W as well. But anyway, let's see. And then N is W cosine 30x degree. Yeah, you see what I mean? Because W here would be cancelled out. So we don't even need to know the mass or even what planet. And that actually means that no matter what planet or what mass you put here, it doesn't really matter. It will still be 38 degrees as long as the material is the same. So at the end, we would have the mu s equals to sine 38 degree divide cosine 38 degree. Actually, if you are familiar with math, you know this is tangent 38 degree. So by using your calculator, you should be able to find out the answer is 0.7812x something. So let's round up to 0.7x because it is 30x, yeah, 38 degrees, so 2SF. Okay, and coefficient of friction is dimensionless, just to remind you. Okay, part B, I clear out what I wrote so to give me more space simply. So part B is basically a different question. So it said it increased the angle to a much larger angle, so for sure that the box would now slide down, and therefore this is the dynamic friction coefficient, so this will be mu d, and then it asks you to calculate the force that must apply to the block along the plane, so it moves up instead, okay, with the plane with acceleration of 1.2. So in fact the free body diagram should also be changed as well, because other than of course the weight and the normal force will be the same, you also have a applied force. So let me just call it as FA maybe, yeah, applied force. And the question is, so what is the direction of the friction then? If you think that it will be the same, then you are wrong, because since it said it's moving up, right, and friction is going always going against your motion, and so in that case it will be going down instead for the friction. So I have to change it to go down instead if you want to push it up. So this is a free body diagram you can do, and the next step will be like what we did earlier, parallel to the plane and perpendicular to the plane again. Okay, so don't be lazy, always try to write down the direction you are handling with, and also the equation F equals to ma as well. Alright, just to give a foundation to your logical thinking. So parallel to the plane, we actually now have three forces, and since it's now moving, so the direction will actually matter. So let me take this direction as positive, and so we should have the applied force minus the friction, because the friction is going down the slope, and not to forget there's also the weight part of it pulling it down, so minus the weight W sine theta as well. So that's why I asked you to memorize it is sine theta equals to ma, and the a will be 1.2, which I might substitute later on. For parallel to the plane, it will, well, actually it's the same, so it will simply be n, well, maybe you can say F equals to 0 like what we did earlier, and it will be the upward equal to downward perpendicular to the plane. So n equals to W cosine theta. So this part doesn't change at all. So since you want to find FA, right? So this is the unknown you want to find. You need to find out friction. Weight already known. This is known. This is known. M is known. A is known. N is unknown kind of, but then you can calculate from this and also angle. So let's not forget there's another equation like part A, which is again the dynamic friction will equal to the mu d, coefficient of dynamic friction, times n. So in that case we can also find out Fd, which is dynamic friction. In here we can maybe put down here as well, and we will be able to find out the applied force at the end. So maybe we firstly find out normal force first. Normal force would equal, well, maybe I just find out at once. How about that? I don't want to be that slow. So let's say 1, 2, and 3. So using 1 and 2, then you should be able to find out Fd equals to mu d. So maybe I'll write by 2 and 1. Then Fd will equal to the mu, which is 0.26 from the question, and then n is W cosine theta. So W is mg, which is 2.5 times 10, and then cosine theta now is 49 degrees. So at the end you should be able to find the answer by calculator, and that is 4.26438 something, okay, Newton. And then I'll keep it in my calculator for this whole value, and then eventually you should be able to find out FA as well, because FA equals to, FA, or just substitute everything we have. So 4.26 minus 25 again, sine 49 degree, M was 2.5, A is 1.2. Alright, sorry for this space here. It should be like this. Okay, so using your calculator, you can find it at once. The answer should be 26.1321 something. Okay, so I will round it up to 2SF, I guess. So 26 Newton will be the answer. If you use 9.81, it might be a little bit off from 26, maybe 25, I guess. So this is how you can handle a question like this. As a recap, I think the only thing that got changed is simply you have to understand the coordinate. You can actually change it. So other than the traditional Cartesian coordinate, which is x and y, horizontal and vertical, you can actually change with whatever angle you like. So doing that can enable you to simplify the question. So what I mean is, you can still, if you really want to, you can still use the traditional coordinate like you learn in maths to handle this question, but it would just be much more painful. So choosing a good tool for a question would be very important.